Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk a little bit about the roll control gain for fin stabilizer systems in early stage ship design. So we're going to use the 50-meter generic yacht to talk about this topic a little bit. And what I want to zero in on first is like, what do I mean by the roll control gain? So, well, when you look at the fin stabilizer configuration, I've got 3-meter square area fins set up on the generic yacht here, kind of at the maximum beam. When you're in build ship in the ProteusDS ShipMo3D toolset and you go to the stabilizer fins, of course you got all the geometry and location, which station is it at and everything. But to make them actually do anything, you need to specify a roll velocity gain. So this is the value that sets the angle of attack of the fins based on how much rolling action there is. And roll velocity gain is the best value to use. It's a very simple approach. It works pretty effectively. But the real question is like, well, what value do I use for this? So we used a pretty small value of 3 to start with. But the next question might be like, well, why wouldn't you just set this to 10 or something really big? And you get a bit of a counterintuitive response at a certain point because, yes, it will help improve ship motion, but at a certain point, the fins get too aggressive and it can actually start making, adding acceleration to ship motion. And we'll show what we mean by that. So in another video, we talked about how you can evaluate, quickly evaluate how fin stabilizers are helping. And we'll look at a couple of examples here with the roll RAO. So just a refresher with the bare hull, we'll look at the roll RAO. And we see at 12 knots in the beam condition, sort of worst case, we've got something like 11 here. Okay, well, let's take a look at now, if we look at the fins with a roll gain of 3, see how that improves things. Look at the 12 knots forward speed and the beam case, and we have 10 times reduction in roll at 1.26 instead of like 11, and so that's a huge increase. Sorry, a huge decrease in roll, a huge increase in performance. Now, well, let's look at another example here with instead of the roll control gain of 3, you look at something much bigger like 10. Does that improve things? Well, let's look at the roll RAO, and wow, it's definitely gone even lower. And you think, well, maybe we should be using this. We really want to smooth out that roll action. That must be the better option. Well, let's look at what the Ship Motion toolset has to say about that. So this is doing an operability analysis considering ship motion across a wide range of conditions and a couple of forward speeds. Here we have the locations of 5 areas. I've got some pre-computed results here with the 2 different roll gain values. So here we have a case with fins, both midships, and this has got a stabilizer roll control gain of 3. This one has a roll control gain of 10. And after all this calculation across a range of sea states and 5 different areas, we look at an overall comfort rating of 54%, 3 stars, for the lower roll control gain value. And the roll control value of 10 has 51%, so it's actually poorer performance. And you start to see why when you start zeroing in on specific case information. So here we have the 12-knot condition, and then when we look at the effective gravity angle values here, we see the Beach Club is exceeding for both of them. But then when we look at the wheelhouse, now the wheelhouse is higher up. It's the highest up location on the whole yacht, right? In these conditions, we start exceeding the limit of 2 degree EGA with the stronger fins, but we're almost passing, but not quite there with the lower roll control gain. So the lesson here is that, yeah, your motion might be lower, but if your fins have a really high control gain value, it might actually start causing problems and causing larger accelerations that can affect the performance in an unexpected way. I mean, essentially you're getting more accelerations and you can reduce the comfort rating. So that was a lesson I kind of wanted to highlight here on evaluating and picking a roll control gain value. You don't really need very much to have some effective control, especially compared to the bare hull. And be sure that you look beyond just the roll RAO and even performance in individual sea state, because it's the accelerations that can get higher, really induced by the fins if you're not careful. All right, that's all for now. Thanks for watching.